Welcome back to number 11. Let's read the question the full way through, and then we'll talk. Point D partitions segment GK in the ratio GD to DK equals 3 to 4. Point G is at 1, 9, and K is at 8, negative 5. Find the coordinates of point D. Okay, let's go through the question piece by piece. Point D partitions. This word partitions means it divides. It divides the line segment called GK according to a certain ratio. Let's get a visual going, a quick sketch. It's not going to be accurate, but it's just going to be able to give us an opportunity to put down all the important information. So let's go. GK. I'm going to have a line segment here. One endpoint is G. The other endpoint is K. Put the points. Okay. Point D is going to partition it. So that means it's going to be somewhere along the line segment dividing it. Let's see how it divides it. It says GD, this ratio, GD to DK is 3 to 4. Now, what does that mean? That means that if GD is listed first, that's the 3. If DK was listed second, that's the 4. So D is going to be located somewhere along this line segment. I'm going to make up a place. So let's say it's right here, and we'll see if kind of that makes sense. I'm going to make it closer to G, and I'm just going to label it as D. So GD to DK is 3 to 4. GD is the 3, so I'm going to put 3 here. And then DK is the 4. So from D to K, it's 4. Now, the ratio 3 to 4 says that there's 3 even pieces. Let's see. 3 even pieces on the left. And then 4 even pieces to the right of D. That kind of makes sense. I made D a little bit closer to G, so it seems like it's all working together. Now, I'm going to erase all those little ticks so they don't distract us. And let's keep going. Point G is at 1, 9. 1, 9. K is at 8, negative 5. 8, negative 5. Find the coordinates of point D. Okay, so this is the heart of the question. They're asking you what the coordinates are. So your final answer needs to be an X and Y value. Our goal is to figure out what is this X and Y value. Now, if it says partitions and you see a ratio, this is a partitioning problem, which you really have 2 choices on how to do. You have the formula, or you have more of like a visual method. I'm going to start with the formula, and then I'm going to show you the visual method. So if I use the formula looks like this. Depends on how your teacher taught you, but this is what it looks like. It is the partitioning point, XP, so the X value for the partitioning point, so this point right here, equals X1 plus K times X2 minus X1. The Y value, same exact formula. YP equals Y1 plus K times Y2 minus Y1. And again, if you're going to use the formula, just write it about 20 times, change the color each time, and it's going to help you memorize this. The more you write it, the closer you are to fully memorizing it. Now, what are all of these variables? Well, XP and YP, those are your coordinates for the partitioning point. XP, YP. The P is supposed to mean partitioning point. The X1, Y1, well, that's your first point. We always start with the point on the left. When they name it GK, they mean they want this point G to be your first point. So it's X1, Y1, and K is X2, Y2. In both of these equations, we're just going to be solving for XP and then solving for YP. The only other thing that we need is the K value. K is a fraction, and we talked about it in the little overview. K is always the part over the whole. Now take a look at your quick little visual. The part is the left part, so starting from G. So this left part, which is 3. So I'm going to put 3 over the whole thing. So from G to K, how many parts are there in total? Well, we have 3 plus 4, so there's 7. So it's going to be 7, 3 over 7. Remember, we got 7 by doing 3 and 4 added together. That's always how we do it. We pick the first ratio, or the first number in the ratio, and then we add together the two parts to give us the denominator. Okay, so we're ready to plug in. Now, I'm going to start with XP. So if I work with XP, I'm going to go ahead and again rewrite the equation or the formula. And now let's start plugging in. So XP is what we're solving for, so we don't have anything. X1 is 1 plus our K value, which is 3 over 7, part over whole, parentheses. X2 is 8 minus X1, which is 1. So we're going to solve. We always start with the innermost parentheses. So XP equals 1 plus 3 over 7. 8 minus 1 over here is 7. And now the next step is we're going to multiply these two things together. 3 over 7 times 7. So if you don't know how to do that math, I'm just going to do it on the side right here. 3 over 7 times 7, put it over 1, and multiply across. 3 times 7 is 21. 7 times 1 is 7. 21 divided by 7 gives you 3. So really what we get here is XP equals 1 plus 3. One more step. XP equals 1 plus 3, which is 4. So our partitioning point has a 4 as an X value. We repeat this one more time, but now we do it with the Y values. So I'm going to go ahead and give myself some room to write. And you should be copying all of this down for your notes. Okay, so the Y value now. YP equals Y1 plus K times Y2 minus Y1, plugging things in. YP is what we're looking for, so we don't plug anything in there. Y1 is 9 plus K, which is 3 over 7. Y2 is negative 5 minus Y1, which is 9. Keep going. YP equals, we're going to work with the innermost parentheses. So 9 plus 3 over 7, negative 5 minus 9. That gives us negative 14. Keep going. Now we're going to go ahead and do the multiplication here. So 3, 7 times negative 14. Put the 14 over 1 and multiply across. 3 times negative 14 is negative 42. And now we're going to do 7 times 1, which is 7. Negative 42 divided by 7 gives you negative 6. So now we're going to keep going. YP equals 9 minus 6, because this whole section here, once we multiplied it together, gave us a negative. So 9 minus 6, which gives us YP equals 9 minus 6, which is 3. So now our YP value is 3. Let's go to our graph to see if this makes sense. So how do we check if it makes sense? Well, you want to make sure that your point is actually partitioning the line segment. Let's go ahead and draw our line segment. G is at 1, 9, and K is at 8, negative 5. Connect the 2 points. And now let's see if the partitioning point is on that line segment. So our partitioning point we said is at 4, 3. Go to 4, 3, which would be right around here. Now, it looks like this is not on our line segment. However, if we kind of just fix our little graph, because it's not great, we grab maybe the side of a ruler or we grab the side of a piece of paper, we notice that in fact, yes, it is. Okay, it's just not great with my little pen on this screen. So it is on the line segment. Now, it looks like the shorter piece, if this is what we call the D, the shorter piece is to the left from G to D. That looks like that's the 3. And then from D to K, that's the 4. So it looks like it makes sense. If we got an answer that was like over here, we know that that would not be correct. That's how you do the formula method. I'm going to now show it to you with a visual method. So I'm going to clear all this off. And we're going to do it visually. Okay, so step 1 is we're going to go ahead and we're going to plot G and K. So again, G is located at 1, 9. And then K is located at 8, negative 5. I'm going to try my best to do this line. Okay. And now, I don't think that was a great line, but I tried my best. Okay, now what we're going to do is we're going to create our right triangle. Okay, so once we've plotted it, our next step is to create our right triangle. Just like we do with the distance formula or finding the length of a line segment, you want to drop a line down and over. So I'm going to drop this line down, keep going, and then over. So once we've created the legs, step 2 is we're going to count the lengths of the legs. So basically, same thing. We're going to find the A and the B. So I'm going to count from G all the way down. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. So it's 14 going down and then across. 1, 2, 3, 4, 5, 6, 7. So 7 across. Once we've counted the 2 legs, let me write that in, that this was 7. Once we've counted the 2 legs, step 3 is we're going to multiply by our K value. So K times your A and K times your B. You're going to multiply them together. So our K value that we figured out before was 3 over 7. So we're going to give myself some room to write here. We're going to do 3 over 7 times 14, that was the rise, and 3 over 7 times 7. So, same thing that we did before. We've seen these numbers before. We're going to do 3 over 7 times 14, so we're going to put it over 1 and multiply across. 3 times 14 gives us 42. 7 times 1 is 7. 42 divided by 7 gives me 6. So now we're going to use 6 for our rise. And then 3 over 7 times 7. Put it over 1 and multiply across. 3 times 7 is 21. 7 times 1 is 7. We divide and we get 3. 6 and 3. How are we going to use that? Let's go back to our visual. And now step 4 is instead of starting at G and counting 14 down and 7 across, we're going to count 6 and 3 to get to our new point. So starting back at G, we're now going to count down 6. So down 1, 2, 3, 4, 5, 6. So this is 6 right here. And then we're going to count across to the right 3. So this was down, and this one's going to go across. So 1, 2, 3. Where we end up should be our point D, which is at 4, 3, just like we figured out with the formula. So it's up to you which method you want to use. This is the visual method, where you're multiplying the A and the B by your K value. Or you could use the formula. It's up to you. Whichever way your teacher taught you or whichever way you like. Okay, let's move on.